Hey guys, it's Vince. Today in this video, we're taking a look at Masso's documentation once again regarding their G3 integrated controller. Now, this video actually stemmed from a end user of theirs contacting me about custom motor cables being made. I then did the video. I posted it actually yesterday, early afternoon, and I started instantly getting a lot of fanboy attacks from the Masso G3 stating that I wasn't being technical with what I was discussing with motor cable lengths and so on and so forth. So that's what drove me to take the video down and actually redo it to make sure I'm being as explicit as possible for any novice end user looking at purchasing this controller. I've already done multiple videos on this unit reflecting that there's discrepancies in their manual as far as any type of wiring diagrams. I did that last week on the HYVFD and actual spindle integration. And now I'm going to show you some things that make no logistical sense. And if you do an open Google search, regardless of what I say, you will find no information on this. So let's jump right in, and we're going to cover this in explicit detail. And you can see here on the Masso, it says all access outputs are differential signals with -4 to +4 voltage signals. Okay, we know that. Let's skip on to that. Not a big deal. When Masso differential outputs can work up to 50 meters when a high-quality twisted pair cable with uniform impedance and low attenuation is used with a suitable differential receiver such as used in the Masso closed-loop stepper motor or the Masso differential receiver module. Now guys, that to me is a bold, ridiculous claim without showing proof of this. And why I say we want to show proof of this, and I want to be explicit for all those guys out there who, once again, are saying, oh, well, you're confusing motor cables and this and that and the other thing. The bottom line is this: your step and direction signals that are right here connected to the drive. You guys were right. I wasn't explicit in stating that the cable length on these are not the power cables going to the actual motor. That's true in certain instances. In the particular instance when dealing with Masso closed loop steppers, that is not true. And why I say that's not true, if we come over here and we look at the Masso closed loop stepper where once again it's discussed using differential signals, and we look here, it states once again that up to 50 meters between Masso and Masso closed loop stepper motor can be achieved when using high quality twisted pair cable with uniform impedance and low attenuation. Well, the reason they're saying that is because the drive itself is mounted to the motor. Therefore, that makes a motor cable. Okay, so once again, we're back at that conundrum of, is this achievable? Or is it possible to have a 50-meter length? And for my guys out there who are like me, who are dealing with imperial because no one goes with meters, just to clarify how long that is, let's look at this. A meter is 3.28 feet. You can look at that online if you'd like. Times 50. That's 164 feet. Now, whether that's going to be using their motors, where the drive is mounted at the motor end, and therefore it would be integrated in the cable, sending those step and direction signals over that distance, or for that matter, if we come back here, and we look at step and direction signals coming from the drive itself, a servo or stepper drive, which you can see right here, that would mean essentially your drive is going to be up to 164 feet from inputting those signals into the G3. Now the question here, and what these gentlemen fail to realize, is that it's interesting when you think if you have a 164-foot cable coming in from just the step and direction signals, I'm being very careful here in saying that, and then you have a motor cable which is going to extend that length even farther going to your motor itself, what do you think you're going to do to the signals? Are we saying that the signals will not be affected by this at all? Because no drive manufacturer recommends exceeding 25 feet on stepper motors, and you can see here we advise that the wiring between stepper motors and drivers not exceed 25 feet in length. Now I know there's going to be technicalities as far as guys saying, well, they're not talking about the power cable. That's true, they're not. What do you think as far as signals are being sent when it comes from the step and direction leads coming from the drive itself? It's just a byproduct of these signals being passed to the motor cables. So if you think in terms of what I'm saying, your motor cables are just as critical as these leads and transfer the exact same signals. Okay, so when I hear guys saying that and saying that, oh, it's not the motor power cable running directly to the motor, it's the actual step and direction signal leads coming from the drive, they are essentially one and the same, guys. You're going to still extend length when you attach a motor cable to your system, and the step and direction leads coming from the drive, if those are already at 164 feet, you're never going to have your motors directly mounted to your controller where the Masso is. So looking at this, just once again, Anaheim Automation states that we advised once again that the wiring between stepper motors and drivers not exceed 25 feet. Who is Anaheim Automation? Anaheim Automation is a major automation distributor, manufacturer of steppers and servos on top of linear axis. They've been in production forever, and they are located in Anaheim, California. You can do this research yourself. Maximum length for a stepper motor cable, excuse the fact that I misspelled maximum, you can see here what we have. If we come down here once again, we look at the ESS, and the reason I want to discuss the ESS, excuse me, is because I think some guys get confused on Ethernet cable lengths when dealing with signals. And what I mean to say is, when you have an Ethernet cable, and this is direct from Warp9's website, which once again is a manufacturer of the Ethernet Smooth Stepper Ethernet controller, if you're running an Ethernet controller where you're using a Cat5 cable to plug into the Ethernet port on the ESS and then run that Ethernet port of the other end of the cable to your actual PC, you can run that up to 100 meters. Now that's a totally different cable than the step and direction signals that are coming off the drive. The other fact is that maximum length for a USB cable is 5 meters. And again, that's really tough to do with USB because, again, it's an insufficient transfer of signals, essentially. It's only running on 5 volts. It's got a lot of grounding issues. We've seen that with Balz's email. I've put that in numerous videos. But once again, I want to clarify, if you're running a Cat5 cable from an Ethernet controller, be it the ESS, the UC400, running that cable from that controller, meaning that Ethernet Smooth Stepper or the UC400 going to a PC can be up to 100 meters. That does not mean your controller, meaning where your drives are, where your breakout board is, those leads inside the controller can be that length. Let's make sure we're on the same page if anyone is confusing that, because once again, you guys want accurate information, and for those technical guys out there who are fanboys of this controller, we're going to cover everything in explicit detail. The other thing is this. I'm not blaming them wholeheartedly. I came here to Drive Tech, and I just did open searches on Google, and I came here and it says, is there a maximum length of encoder cables? Now what's interesting here is this gentleman is claiming to be a motion control specialist, and somebody says what measures you have to pay attention to when long encoder or hall sensor cables are involved. Standard cables in use by motors and sensors might just have a length of 30 cm up to 3 meters. Sometimes this is not long enough, especially if controllers are installed in a cabinet of a machine, which might be placed some meters away or even in another room. And then he states here, there is no general answer concerning the maximum cable length. A cable length of up to 10 meters can be handled without any problems. I agree with that. That statement I totally agree with. It's been proven before. If some special measures are taken into account, even cable lengths up to 50 or 100 meters have been successfully in use if anything is installed in a perfect way and the signal quality is checked and confirmed during initial commissioning. Now, guys, I'm telling you right now, it's interesting he would make a statement like that, or I should say an opinion like that, because there's nothing surrounding that. There is no proof of that. I've never seen that done. And I've never seen, again, especially with an encoder where we're dealing with a servo, that would mean both cables would have to be that long. That means the cable going to the motor as well as the encoder cable. So that would mean no corruption in either of those cables in any sense or form. And once again, he says in a perfect way. Well, there is no perfect way. We know that in engineering. And then he comes over here and it says encoders typically have a tight tolerance concerning the supply voltage. In case of 5 volt, positive negative 5% specification, this means at least 4.75 volt has to be present. Well, that's interesting because as we come down here, he's going to talk about voltage drop, has to be present in the encoder's supply voltage input to ensure its operation. The voltage drop of long cables can get critical from the supply voltage's point of view. If the supply voltage is not sufficient, the sensor signals will not be present. That is totally correct. Wrong or sometimes missing. The root cause of missing pulses is often the supply voltage and not the signal level like expected. Therefore, it's important to ensure that the specified supply voltage is present at the encoder's connector. This can be improved by using thicker wire gauges inside the cable. Actually, such thicker wires are just required for the supply voltage and ground wire. The voltage drop of the sensor wires is not so critical like mentioned above. Well, guys, once again, I would have to disagree with that. Every cable is critical. You're carrying signals. Any voltage drop is going to affect those signals' reception. And if you don't believe that, I'm talking about stability. When I talk about stability, I talk about it in real world use. I'm not talking about a guy on the internet showing you his system move back and forth like so many of these guys do. Okay? Now, when we think of the guys, and this is what I get such interest in, is I think of the guys that make the comments who are fanboys of this controller representing these kind of claims, is you click on their link to go to their site. As far as on YouTube account, they never have any feedback, they never have any videos, nothing. They make claims, and these are the same guys, the majority of them, that are in these forums making these claims and supporting them because they use their controller and they feel it's great. Well, you know what? That's fantastic. Just don't try to pull the wool over people's eyes in the sense of what's possible and what isn't without verifiable proof. Okay? Once again, making claims like this with no proof doesn't make sense. So I can see confusion on both ends, meaning I can see that there are guys out there saying, you know, like this gentleman where he states, oh, this has been done, you know, for all, you know, long lengths of time, and that's why there's not a video proving it. Well, that doesn't make any logical sense. If the internet shows with a Google search that we can't find a video proving anyone ever going that long with signals, I would say it defines pretty much it's never been done because there's no requirement to do it. Okay, number one. Number two, it's extremely costly. The cost of a double shielded 18 gauge UltraFlex cable like my DS Flexion, that even at my wholesale cost of $2.60 a foot, is $260 on a 100-foot cable. So what do you think it's going to cost at 164 feet? Think logically, guys. None of this makes any sense logically. And that's the whole point I'm trying to make. When we look at this, and we look at manufacturer recommendations on motor cable length where, yes, technically speaking, we are talking about step and direction signals here and not motor cable length. However, they essentially affect each other. The signals they're carrying are the same, whether one is going to your drive direct or from your drive, or for that matter going to the motor. It's still the same signals. It's all coming from this board and coming from this drive, or whether it's right here, the cable as an intermediary going to plug into the Masso, or it's on the other end. The thing to keep in mind is the closer your drive is to the Masso, the better off you are. Okay, the reason this statement was made was once again because of their closed loop steppers, which have an integrated drive into them. Okay, and then if we come down here, once again, it's very interesting where it says under information, and this is dealing with their own motors, guys. Use shielded twisted pairs between Masso and the motor for step and direction differential signals. This will provide the greatest noise immunity. This is true. You should be using double shielded cable. Ensure that the shield is connected to the ground at the Masso end only. Do not ground the shield at both ends or you will create a ground loop. Well, that's great. Once again, and I'll just point this out, and I want to hear their fanboys explain this. Where does it say there that a professional should be connecting and working with the Masso to build your controller? It doesn't. It's assuming a DIY attitude, meaning their whole premise is to sell you a controller that you're going to build yourself. Well, that'd be great if they actually provided the information required to do that. So whether you're a fanboy of the unit or not, you can't argue with the fact that they're making direct statements here. Do not ground the shield at both ends or you will create a ground loop. And they're telling you basically how to wire something without definitively showing it. And that's really interesting. There's no grounding present here in the sense of a ground bus or anything like that. And then over here, this is where it gets really interesting. AWG 24 gauge cable. That's 0.2 millimeters in diameter. I want you guys to think about that. 0.2 millimeters. to 22 gauge, which is 0.3 millimeters in diameter, is suitable for signal wires. Ensure the wires are multi-stranded and twisted. Well, twisted wires do help mitigate some noise. They are not even close to being as effective as double-shielded cables, as double-shielded cables essentially have a Faraday cage around them acting as a filter. And that's the whole idea of double-shielded cables. It's also why double-shielded cables are so expensive. It's amazing they're so confident to say that these leads, whether it be a motor cable in this case, which is a motor cable due to the fact that, once again, it's a motor with the drive, actually the driver on the back of it, they don't show that this could be up to 50 meters in length. It's interesting. They just talk about it, but they're not showing this. This is the area that they're saying can be up to 164 feet in length. That's ridiculous, guys. And to say that and not show it, showing that the system is stable at that length, it creates mass confusion, regardless of what you believe. Now, once again, that's only using this motor, which is their branded unit. Now, we all know closed loop, stepper, servo, whatever you want to call it. The bottom line is this: they're all going to be susceptible to the same signal impedance as far as actually dealing with any type of interference at that level. Now, of course, we use double shielded cables. That's going to mitigate that interference if the system is built correctly. But we're still dealing with voltage drop. Now, I brought this up. And when I brought this voltage drop calculator up on the previous video, I had that guy once again say, well, you put it in at 3 amps, because I was discussing the motor cable end. And when I'm saying the motor cable end, dealing with a branded motor that was not a proprietary motor of Masso. And I had it at 3 amps. But he brought up that I listed it at 3 amps here, and step and direction signals are never 3 amp. Well, you're absolutely right, sir. But let me clue you in on something. Let's look at these measurements. Wire diameter size is 18 gauge, which would be standard for motor cables. And if it's not going to be 18 gauge, and we were going to go up with this to, let's say, 24 gauge, and we say wire cable length at 164 feet, current type DC, voltage in volts, 5 volts, and we're going to say current in amps, which is typically 0.5. Okay, if we calculate that, your voltage drop right there is 4.19 volts. And this is looking at this calculator. Now, in no way, shape, or form is this 100% accurate. None of them are, guys. This is where theory comes to logic. And this is where true engineering comes in. First, you look at the theory, then you prove your actual concept of theory. Okay, that's how real engineering works. We don't make statements on something unless it's been proven. Okay? That's why when we look at facts of real engineering, they just take cars, for instance. Elon Musk doesn't release a car without physically testing their engineering theories behind it. There's no denying this. It's right there in front of you. And even if we go to 22 gauge leads at 164 feet, calculate, you still have a voltage drop of 2.64 volts. This is undeniable. It's undeniable that this range is definitively possible. Percentage of voltage drop is 52.82. Are you telling me that's not going to affect the system, or even potentially affect the system? Because I myself, in all honesty, have not tested it at all. But at least I can say that and say that without me manufacturing this controller. When I see things like this, and it's funny, even one of the guys that commented, he said 50 meters is actually going a long way, or it's it's a bold claim. Well, saying that and not showing it, and that's the thing that makes really no sense, is confusing. And let me explain why it's confusing as a vendor myself. If I developed this controller, guys, and I said, or I knew that this unit could actually handle that kind of signal reception at that distance, it would make this controller stand out above everything else, because essentially what they're saying is you could have this controller itself, an electronic end as far as the Masso G3 unit, this board, inside an office and have your machine somewhere around 200 feet away. I mean, that's a massive claim. It's a massive claim, and it's a massive selling point. Who would leave that money on the table? You'd make that a point so that you would actually increase the selling percentage of the unit. That tells you something is amiss. The other thing is, we talk about this twisted pair of cable that they're recommending. Well, once again, we're making recommendations here without even telling you what cables they recommend, which should tell you right away they've never tested a cable in conjunction with that length. And this is just pure logic. Who would do that? I mean, it doesn't make any sense. No one would leave the money on the table. They could become an affiliate or carry the cable themselves and make a fortune. Unfortunately, what's being fact here is we're making claims without any verifiable proof. And when I see guys that confuse things even more for end users, it's scary. And like I said, I'm not blaming them by themselves. This is a direct post from somebody claiming to be a motion control specialist. But when we say 50 to 100 meters has been successfully in use, when we do an open Google search of that, I've never seen an encoder cable ever go past 30 feet. And that's a fact. So, I mean, that's really pushing it in itself. We're not talking about large voltage limits. He just said it right here. So it's kind of contradictory. And then to say that voltage doesn't really play a role, well, everything with electronics is based on voltage. Every cable that is in excess of any length is susceptible to voltage drop. It's a byproduct, guys, of resistance. So if you want to check this out and you want to confirm it, you confirm it. The big thing here is let's not try to convolute the waters for guys getting involved with this system. Let's tell them the truth. That is totally crazy without seeing verifiable proof of that if the system has not been deemed stable. Once again, when I say stable, I'm going to define what I mean by stable and what everyone out there I believe would affirm is stable. It doesn't mean showing jogging back and forth for a quick YouTube video to market this unit. It means showing a job being run in excess of 18 hours like most guys do to profit with this system and show that this machine is stable. Matter of fact, do it for a week. If you're making a bold claim like that, whether it's a day or a week, it shouldn't matter. It's just going to take you time to set the camera up and leave it there. So again, I'm telling you right now, when companies make claims like this and don't show it, that's a bold claim to make. And, and basically what they do show, and this is interesting, we come down here, they're saying their differential receiver module, just to make sure we're clarifying that. This little board is basically taking all these drives, which once again are some of the example drives that do not support differential signals. You can see the G203 right there. And again, they've got the wiring here. The below diagram shows a Gecko G203V drive that takes TTL signals with a common negative, mount the differential receiver close to the drives. So they want this receiver close to the drive. So this would be essentially in your electronics enclosure with the drive, and then you can have that 164-foot cable because they're boosting the signal, essentially is what they're trying to say, from 12 to 24 volts. Yet up here, the Masso differential receiver module can be used to control up to 5-axis drives and also provide 5 volts so that no external 5-volt power supply is required. Once again, we jump up to 12 to 24 volts and that's said to be done. You are still going to experience voltage drop. And you will see that now here. And once again, is it going to be as much? Of course not. You're still going to see a voltage drop at 2.64 volts at 22 gauge wire, which I have no idea why you would ever use leads that small or recommend leads that small over that distance. I mean, that is crazy. We know that a thicker gauge wire is going to have less resistance, provide a more adequate transfer of electricity. That does not make any sense whatsoever. And I'm speaking as an engineer. You would never want to go beneath 18 gauge. And just to prove that, we go to 18 gauge, excuse me. You can see, if we calculate, you see your voltage drop dramatically, meaning you're actually increasing more voltage to go through that cable because, again, we have less resistance. So looking at this and once again going through all of these parameters that they've given us as far as details about what they're doing, and again, this is not one drive, they're saying all these drives. Wiring example 4-wire optically isolated, and now they're showing you this. And once again, I'm going to point it out, I did this in my last video, you can see their wiring diagrams. As generic as can be, end users look at this, they see the lead coming over here and they see it goes, okay, step negative and direction negative, and it merges. What they're not showing is a correct terminal splitter to actually join those leads together. So what do guys do? They daisy chain it together. Meanwhile, the drives manufacturer will always say do not use daisy chaining. But they don't even confirm that right here in their controller. So regardless of what you choose, I want you guys out there, and I'm talking about the novices, not the guys who've already purchased their unit, are content with it in the sense that, hey, I don't care what's best practice. I care that I've already got the unit wired and I don't see issues. These are the guys that make comments. They're the guys that are continuously validating a controller because they find that they're happy in their particular instance, which is great. The issue is this: novices looking at this think differently than you do in the sense that, hey, I want to start right and I want to do things right and understand best practice so I know what I'm getting involved with. And that's the guys I'm really pointing this to. Differential signals do provide more immunity to EMI. That's fact. I mean, there's definitely a benefit to using them. However, let's not make claims that can shoot yourself in the foot, especially when they haven't been proven with your controller, let alone controllers online. I mean, we're hearing about this, that this has been done for years, and that's why no one said anything. I disagree with that. We're talking about two totally different entities when we're talking about motor cables. And in this instance, with their own motors, we're talking about a motor cable. And do your homework. There is no perfect controller, that's a fact. Whether it be a Gecko, whether it be a Masso, there is nothing that's absolutely perfect. They're all going to have little quirks here and there. But making, like I said, bold claims, for my guys out there who are looking to spend their money, and once again, it's hard-earned money, and these units are not cheap, making claims like this is convoluted. It confuses you. So look at this carefully, study it. Study the voltage drop calculator, rapidtables.com. You can go on a different site. Once again, I left the resistivity the same. You can put in whatever numbers you want here. It'll give you a baseline. Once again, it's not exact, but it does show you what you're dealing with. And voltage drop is real, and we all experience it. So again, guys, I hope that this video, being more explicit and more detail, has covered everything. And regardless of guys who already have this system and are happy, God bless you. For the guys looking to buy a system, know what you're getting involved with. Understand that if you purchase this unit, there are certain things that are being said that you really need to double check. As a matter of fact, and this I said in the previous video, and I'm going to say it again, when you're looking at stuff like this and you have questions like this, go directly to your drive manufacturer. The thing about CNC equipment and hardware, especially electronics, is that a lot of times other vendors do not realize, manufacturers in this case of components, they have to be working in conjunction with other components. That means compatibility has to be there. So you can call your drive manufacturer, or should be able to if they're supporting their drives, and ask them what kind of compatibility is possible when statements like this are made. Do you see any issues with this? Because I find it really hard to believe that a drive manufacturer would say, no, that's possible, do it, and we'll be responsible. They're not going to do that, guys. I'm telling you right now, that's not going to happen. I've been dealing with this well over a decade as far as automation, and I could tell you right now, I've never, ever seen that. I've never seen claims like this. So think about it. You always have steps to get your resources with more information, whether it be Google, whether it be the drive manufacturer. Asking these questions will protect you in the long run and make sure that your money is safe. So again, guys, I want to thank you all for your support. I hope that this video has been explicitly clear. I hope you think about exactly what I said and ask the right questions. Take care.